Hello, welcome to the video. In this lesson, we're going to be looking at section 6.5, where we're going to use indirect proof and inequalities in one triangle. So first off, we are going to learn how to write an indirect proof. And then after that, we're going to look at characteristics of inequalities in triangles. So first off, let's look at indirect proofs. So indirect proofs, here's how are the steps that we're going to look at for an indirect proof. So for the first step, it says identify the statement you want to prove. Once you've identified the statement, you're going to temporarily assume that that statement is false. All right. But assuming that its opposite is true. You're going to use logic to reach a contradiction, and then because of the contradiction, the conclusion must be true. All right, so for instance, here it says write an indirect proof that in a given triangle there can be at most one right angle. All right, so a right angle means that one side is um, exactly 90 degrees. Okay, so what they are saying is that there can be at most one right angle. So here we're going to prove that triangle ABC has at most one right angle. So step one is we're going to assume temporarily that the statement is false. So the statement is false, meaning let's say we can have two right angles in a triangle, which means that if we were to use the triangle sum theorem states that the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 in any triangle must result in 180 degrees. So if I have two right angles, that means I have two 90-degree angles. So right here I have 90 plus 90 plus, I'm not sure what angle 3 is going to be, and that's going to be equal to 180 degrees. Well, 90 plus 90 is already 180, so this would have to be 90 plus 90 plus 0 equals 180. Well, since I can't have an angle of 0 for my third measurement, this is a contradiction to um, my temporary statement that's false. So that means that this proves that a triangle can have at most one right angle. So here it's asking us to write an indirect proof that a scalene triangle cannot have two congruent angles. So scalene by definition has no congruent sides. So they're talking about a classification of a triangle with side measurements, and then they're asking like, well, it cannot have two congruent angles. So here's what we're going to do. We're going to um, temporary assume that we have two congruent angles. All right, so they said they cannot have two congruent. So we're going to temporarily assume that it has two congruent angles. So let's say I draw an arbitrary triangle A, B, and C. So two congruent angles will say that angle A is congruent to angle C. All right, with that, we can now say because of the base angles theorem that AB would be congruent to BC because of those um, two congruent angles. So since we now have two congruent sides, they are not scalene. So this is a contradictory to my temporary statement, which means that um, this proves that a scalene triangle cannot have two congruent angles. Here, they're asking us to draw an obtuse scalene triangle. All right, so obtuse means that one of the angles is greater than 180, and scalene means I have no congruent sides. So I'll try to do the best I can. So I got here, I'm gonna make, so, so this is my obtuse angle. So just to reference that, here it says find the largest angle and the longest side and mark them in red. Then they want you to find the smallest angle and the shortest side and mark it in blue. What do you notice? So my obtuse um, angle is going to be my largest angle. So I'm going to mark that in red. And by looking at it, my longest side is right here. All right. My shortest or my smallest angle is going to be right here. And my shortest side is right there. What do I notice is that the shortest side is opposite to the shortest angle, and the longest side is opposite of the largest angle. Well, we have a theorem that proves that. So we have what is called um, a triangular longer side theorem. So if you see two sides, one side is larger than another, we can then say that the opposite vertice is going to be larger than the opposite vertice of the smaller side. So here it says since AB right here is greater than BC right here, we can then conclude that the opposite angle here, C, will be larger than the opposite angle A in this particular triangle, and vice versa. If you had angles, if you had one angle that's larger than the other, so they're saying that angle A is larger than angle C, we can then say that the opposite side here, BC, is going to be larger than the opposite side, AB, in this particular instance. So with that being said, what we have, it says you are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is about 32 feet long. So I'm just going to write 32 feet. The left slope is about 24 feet long. So I'm just going to write that in. And the right slope is about 26 feet. They're asking us to list the angles of triangle JKL from smallest to largest. All right. So these angles from smallest to largest will be as follows. So first thing I'm going to do is I'm going to look for the smallest side. So the smallest side right here is 24. The opposite angle in this case is angle L. So angle L is going to be my shortest angle. Next, I look at my next smallest value, side measurement is 26. I look at the opposite, it's J, so angle J is my next. My largest side measurement is 32. Opposite of that is angle K. So angle L, angle J, and angle K would be my smallest to largest angle measures. Here they're asking you to list the sides of triangle DEF in order from shortest to longest. All right, so in order to do this, I need to find all the measurements of my angles. So, utilizing the triangle sum theorem, you're going to take 180, and I'm just going to subtract it by the sums of 51 plus 47. And when I do that, I get 82 degrees. So now knowing that, I know that my smallest angle measure is 47. Looking to the opposite, so that means that DF is my shortest side. Next, 51 is the next value, so that means that FE is my second smallest. And then my largest value comes opposite of the 82 degrees because of my largest angle. So that means DE is my largest or longest side. Same rules here, looking at triangle PQR. They give us the side measurements. They want the list of angle measures. So 6.8, 6.1, and 5.9. My smallest distance is 5.9. Look at the opposite, angle Q. Next, 6.1, so opposite will be angle P. And then my largest angle is going to be angle R. From here, looking at my angle measurements, my smallest angle measurement is 29. Look at the opposite. It's going to be line segment ST. Then I get 30. Opposite of that, line segment RS. Finally, my largest angle is 121. Take the opposite of that, and that is line segment RT. All right. Last theorem of the notes is talking about a triangle inequality theorem. So what it states is for side measurements to be a triangle, the sums of the lengths of any two sides of a triangle is greater than the length of the third side. All right, so in order for three measurements to be a triangle, these three statements must be true. AB plus BC must be greater than AC. AC plus BC is greater than AB. And then finally, AB plus AC must be greater than BC. So before I get to number 4, I'm going to look at either 5, 6, or 7. So they want to know if is it possible to construct a triangle with the given sides. So looking at number 5, what you got to do is you have to show all three inequalities to see if it holds true. So first off, I'm going to look at 4 plus 9. I want to see if that's greater than 10. All right, 4 plus 9 is 13. Is 13 greater than 10? That's true. It checks out. Now I'm going to look at the next set. So I'll go to 9 plus 10. I need to see if that's greater than 4. 9 plus 10 is 19. 19 is greater than 4. It checks out. Finally, the third set, I am going to look at 4 plus 10. I want to see if that's greater than 9. I get 14. Is that greater than 9? Checks out. Since I showed it in all three scenarios, that could be my explanation. And I can say that 4, 9, and 10 would in fact make a triangle. If you looked at 6, the first one would be like, oh, 8 plus 9, I need to see if that's greater than 18. Well, 8 plus 9 is 17. 17 is greater than 18? No. So I can stop. So this one would not make a triangle. Same thing goes for 7. So if like I did 5 plus 7, that has to be greater than 12. Is 12 greater than 12? No. So this one would not make a triangle. Looking at this example here up on top, number 4, here it says a triangle has one side of the length that's 12 inches and another side of the length that is 20 inches. They want you to describe the possible lengths of the third side. So here's how you're going to go about in doing that. So again, you got to use all three different scenarios in order to create um, possible values for the third side. So what you're going to do is you're going to look at, let's say like 20 plus 12 is greater than the third side, we'll call it x. So 20 plus 12 is 32. 32 is greater than x. All right, so whatever the value of x is, it must be smaller than 32. Okay, now if I picked another set of values, so let's say I went 20 plus x, that has to be greater than 12. Well, if I subtract 12 from both sides, or 20 from both sides, I'm sorry, this now becomes x is greater than negative 8. Well, it can't have a negative distance, so that kind of gets omitted. So now the next one is 12 plus x, that has to be greater than 20. So subtract 12 from over here, x must be greater than 8. So my result here is x must be in between 32 and 8. And that is using indirect proofs and inequalities in one triangles. Hope this helps. Until next time.